This video, the fourth in our series, is going to cover double replacement reactions. Double replacement reactions is simply another name for a metathesis reaction. The thing to differentiate metathesis reactions from redox reactions we've seen up to this point is that there isn't going to be a change in our oxidation states. As stated, a metathesis reaction is going to involve rearrangement of the atoms without changing the oxidation state of those atoms. There are many different types of reactions that fall into this category, but we're going to focus mainly on reactions that occur in aqueous solution between two ionic compounds. The general format is simply going to be our ionic compound AB reacting with ionic compound CD, and as you can see, our A and C will have traded places. Our cations are A and C, our anions are B and D. It's actually easier to see these in action. So in a double replacement reaction, you first identify it as you have two ionic compounds. A and C are going to trade places. So our first compound we can predict is going to be a compound between A and D. Notice that the C has been traded places with the A. The other trade is going to be the C replacing the A. So we have compound CB. The reason why the arrangement again is that A and C are our positively charged cations, and those come first in our compounds. So let's see how this is applied to actual compounds. In hydrochloric acid and sodium hydroxide, in the reaction, the hydrogen and the sodium will trade places. Those are both our cations. The hydrogen is a +1, sodium is a 1+, chloride is a 1-, and the hydroxide is a 1- as well. When we go to predict the first product, we can predict it as hydrogen hydroxide, or we can call it water because it's the formula for water. We have just shown the ions and how they're arranged a little bit differently. But notice that our hydrogen and our sodium have traded places. The sodium and the hydrogen are going to trade places with forming sodium chloride. Since everything has the same oxidation states, we don't have to worry about balancing our charges on the product side. So this is our final balanced chemical equation. In a reaction between zinc chloride and lead 2 sulfate, again, we're going to have our zinc and lead trade places. They are our cations. So zinc is a 2+, lead is a 4+. Since they are the cations, they will trade places. Our first product we can predict is going to be the zinc with the sulfate. Now this time around we've seen that we drop that subscript 2 on the sulfate because zinc is a 2+ and sulfate is a 2-. We only need to have one of each of them. The other product is going to be lead chloride, but lead's going to have a 4+ charge, so we have to have 4 chloride ions to balance that out. We also then include our coefficients of 2 for the zinc chloride and the zinc sulfate to make sure that everything balances out properly in the end. But this is our double replacement reaction. You simply take our metal ions and trade their places on the product side. And when you predict those products, you make sure that the charges are balanced properly to give you the correct formulas, and then you balance the equation.